This is the OCR GCSE Maths Paper 5 covering the higher tier, and it's from the November 2019 series, and it's a non-calculated paper. Question number 1 for part A, we have to work out 3/4 plus a sixth, giving an answer in its simplest form. Well, over here, we would have 3 times by the 6 plus 1 times by the 4 all over 4 times by 6. So on the top we have 18 plus 4, which is 22. On the bottom we've got 24. So therefore what we'll end up with is 22 over 24, which if I divide the top and bottom by 2, would end up with 11 over 12. So we have 11 over 12. And now for part B, by writing each number correct to one significant figure, we have to use estimation to show that 39.6 times 20.2 over the square root of 99.2 is approximately 80. Well, 39.6 to one significant figure, that's 40. 20.2 to one significant figure, that's 20. And then 99.2 to one significant figure, that's 100. So what we have over here then is 40 times 20 over the square root of 100. So we have 800 over 10. 800 over 10 is simply 80. And therefore, this is exactly what we wanted to show. Question number 2. Given that 168 is equal to 2 cubed times 3 times 7, we have to find the lowest common multiple of 168 and 30. Well, if we consider this 30 we can split up as 2 times by 15, and 2 is a prime number and 15 isn't, so the 15 we can split up further as 3 times by 5. So what we've got already is 168, which is equal to this is equal to 8 times by 21, which is the same as the following. So I'm just rewriting the 168 in terms of what's just given. So when we come to find the lowest common multiple, they both contain a 2. They both contain the 3, and that's it. And then we multiply the others, so we've got 2, this 2, this 7, and this 5. So multiplying everything together, we have 4 times by 2, which is 8, times by 5, that's 40, times by 3, that's 120, and timesing that by 7, we get 840. So we end up with 840 as the lowest common multiple. Question number 3. Martina has answered some questions on algebra. In each question she made an error. We have to describe her error and give the correct answer to each problem. So for question 1, we were asked to simplify 2a times a times a, and her answer she put was 4a. Well, in terms of her error that she made, what she did was she added the 2a, the a and the a together to give 4a. So what she did was she was adding the terms, and in terms of the correct answer, well, we'd have 2, and because a is being multiplied by itself 3 times, we have 2a cubed. And now for part B, when simplifying x to the 10 over x squared, the answer they got was x to the 5, so when we come to identify the error, well, they divided the 10 by 2. So she divided the powers, so she should have subtracted the powers, giving us x to the 10 take away 2, which is just x to the 8. That's what we should have got. We should have got x to the power of 8. And question 3, we're given s equals ut plus a half at squared. We have to find s when u is 0, t is 5, and a is 6. So when her solution, she did 0 times by 5, that's correct, plus a half lots of 6 times by 5 squared, so this so far is correct. And then she made an error. Over here what she did was she worked out a half times by 6 times by 5 all squared. So this 15 squared is wrong. So what she did was she worked out a half lots of 6 times by 5 all squared. So when we come to write down the correct answer, what we should have done is square the 5, then times by 3. So what we should have done is work out 0 plus 3 times by 5 squared. So we would have had 3 times by 25, which is 75. So we should have got 75. Question number 4. In 2017, a chocolate bar had a mass of 250 grams, and in 2018, the mass of the chocolate bar was reduced to 220 grams. We have to work out the percentage decrease in the mass of the chocolate bar from 2017 to 2018. Well, over here, we need to work out the difference. So, the percentage decrease, that's equal to 250 take away 220 divided by the original 250, and then we multiply this by 100. So we have 30 over 250 multiplied by 100. So we've got 3 over 25 times by 100. It turns out here 100 divided by 25, that's 4. Timesing that by the 3, we get 12% as our percentage decrease. Question number 5. We have to solve 6x minus 10 equals 4x plus 1. Subtracting 4x from both sides, we end up with 2x minus 10 equals 1. Adding 10 to both sides, we have 2x equals 11. And dividing both sides by 2, x is therefore equal to 5.5. So x is equal to 5.5. Question number 6, we have to solve by factorising x squared plus 9x plus 20 equals 0. Well, what we are looking for here are two numbers which multiply to give 20 and which add to give 9. You'd find these two numbers to be 4 and 5. And therefore what we have is x plus 4, lots of x plus 5 equaling 0, so either the x plus 4 is equal to 0, in which case x is equal to minus 4, or the x plus 5 is equal to 0, in which case x is equal to negative 5. And so therefore we have two solutions for x, minus 5 and minus 4. Question number 7. Sundip and Emma have some money. The ratio of Sundip's money to Emma's money is 3 to 5. Emma spends £450 of her money. The ratio of Sundip's money to Emma's money is now 2 to 3. We have to find out how much money Sundip has. Well, what we will do to begin with is Question number 8. The diagram shows a kite ABCD. AFE and CEF are equilateral triangles. So if we have equilateral triangles, that means this length is the same as this length, which is the same as this length. That's for that triangle. And because here we've got an equilateral triangle, this length is the same as this length, which is the same as this length. And if we add on some angles, we've got 60 degrees here. We'd have 60, 60, 60, and 60 degrees here. And we'd also have 60 degrees here. So that's just using the information we've been given already. Now for part A, we have to write down the mathematical name for the quadrilateral AFCE. So AFCE, we got AF, CE, that's this one that I've highlighted over here. What you can see is, because we've got everything being the same sides, but we don't have a square, you can conclude here that we have a rhombus. Now for part B, the ratio of the angle DAE to the angle EAF is 1 to 4. We have to work out the size of angle X. We write on the diagram the values of any other angles we use out in our working. Well, this angle is a quarter of this angle, which is 15. So we have 15 degrees over here. Now angles on a straight line sum to 180, so this angle here is 180 take away 60, take away another 60, which is 60. So we've got 60 degrees over here. Now angles in a triangle would sum to 180, so we have X plus the 60 degrees plus the 15 degrees. All of this is equal to 180. 60 plus 15, that's 75, so we've got X plus 75 equals 180, and therefore X is equal to 105. We have X equaling 105. Question number 9. For part A, the scale 1 centimeter represents 25 meters can be written in the form 1 to k, and we have to find the value of k. Well, over here, we can convert the 25 meters into centimeters. To go from centimeters to meters, we would have to divide by 100, and to go from meters to centimeters, we'd have to times by 100, and therefore 25 times by 100, that's 2500. And therefore, we have k equaling 2500, as so. And now for part B of the question, the scale drawing represents a harbour, and we were told that 1 centimetre represents 25 metres, and in this question, a boat leaves the harbour from point C and sails on a path that is equidistant from BC and CD. The harbour rules do not allow boats to sail within 75 metres of point E, and we have to find by construction whether the path of the boat will follow the harbour rules. Show all your construction lines. Well, first of all, you see here that we've got something which is equidistant from BC and CD. So what we can do is draw a perpendicular bisector. So put the pointy bit of your compass on point C, and if we intersect the lines B, C and CD like so, we've got an intersection here and an intersection here. And now from here, draw lines like this, keeping the same radius. Got the same in the opposite direction too. Okay, so just make sure that everything is the same. Yes, it is. So now, if we join these up with a straight line, like so, we've got here this line. Okay. So that's that statement sorted. And then it says, the harbour does not allow boats to sail within 75 metres from A. Well, if we use the scale, we know that 1 centimetre represents 25 metres. So here 75 metres will... Question number 10. On a plane, 2/5 of the British passengers were... 2/5 of the passengers were British. 30% of the British passengers were men. There were 36 British men on the plane. We have to find the total number of passengers on the plane. Well, we begin by letting the total number of passengers equal x. So of those passengers, you can see then that we have 2/5 of those who are British. So we've got 2/5 x. This 2/5 x would represent the number of British passengers on the plane. And then 30% of these were men, so we times this by 30%, which is the same as 3/10. So the reason we are timesing by 3/10 is because 30% of these passengers were men. And we know in total we have 36 British men. So this 36 corresponds to the fact that we've got 36 British men. So we have here 6/50. So we've got 6/50 equals 36, rather 6x/50 equals 36. And if I divide through by 6, you can see that x/50 is equal to 6, and therefore x is equal to 300. So just to confirm what I did over here, I divided both sides by 6. So this will cancel with this, and then 36 divided by 6 is 6. So therefore, the total number of passengers we have on the plane will be 6. Question number 11. A bag contains 100 pencils that are either red or green, and we have to describe a method you could use to estimate the number of red pencils in the bag without looking into the bag or have more than one pencil out of the bag at any one time. The first thing we do is we select a pencil from the bag and record the results. And then what we do is we put the pencil back into the bag. We then repeat this at least 10 times. We could repeat it more times if we wanted. The more times we repeat it, the better estimate we would have. We then find the relative frequency, which is given by the number of red pencils divided by the total number of trials, and that's in this case. And then our fourth step is to recognize that the relative frequency times by 100 gives us the estimate, and of course we've got 100 pencils in the bag. Question number 12. The box plot shows the distribution of the marks scored by some boys in a test. And for part A, we have to find the interquartile range. Well, what we need is the upper quartile take away the lower quartile. So for the interquartile range, we have the interquartile range equaling the upper quartile, which you can see here is 64. So here is the upper quartile, it's 64. Take away the lower quartile, which you can see here is 49. So we have here 64, take away the 49, which you will find to be 15. So the interquartile range is 15. Now for part B, the marks for some girls in the same test are summarised below. We've got the median being 58, the lowest mark being 32, the range being 44, the upper quartile being 66 and the interquartile range being 12, and we have to draw a box plot to show the distribution of the marks scored by the girls. Well, first of all, let's add on the median. So for the median we've got 58, so 58 that goes over here. We've got here 58. We've got the lowest mark given as 32, so we've got 30, 31, 32 over here. And we've got the range equaling 44. Well, how does this help us? Well, what you can see then is the range is equal to the maximum take away the minimum. So this here is equal to the range. And therefore what you can see then is the maximum equals the range plus the minimum. So therefore what we'd have here is the maximum equaling the range, which is 44, plus the minimum, which is the lowest mark, 32. So here we get 76. So therefore the maximum value is 76, which is over here. And using the fact that the interquartile range is equal to the upper quartile take away the lower quartile, so this is equal to the interquartile range, what we can see here then is, well, we've been given the upper quartile. What we need to do is find the lower quartile, so therefore for the lower quartile that's equal to the interquartile range, rather it's equal to the upper quartile take away the interquartile range. So we've got the upper quartile equaling 66, take away the interquartile range, which is 12. So here we would get the interquartile range being 50, rather the lower quartile being 54. So we've got 54 for the lower quartile, we've got the upper quartile being 66, so 66 is over here. So if we show on the upper quartile as 66, joining all these with a straight line, as we see here, and then joining these up, here is our box plot. And now for part C, what we're told is, Eleanor says the boys did better on average in the test as they had a bigger interquartile range. We have to see if her statement is correct, explaining our reasoning. What we see is the interquartile range is a measure of spread, not average. If we were to look at the average, we'd look at the median instead. Question number 13. For the first part of part A, we have to write 1/3 as a recurring decimal. Well, we know that 1/3 is equal to 0.333333, etc. And we could go on forever. And what you'd find this to be as a recurring decimal is 0.3 with a little dot on it, like that. And then we have to write 1/30th as a recurring decimal. Well, 1/30th is 10 times smaller than this, so we'd have to divide this value by 10. So we'd have 0.03 recurring, like so. And for part B, we have to simplify fully by rationalizing the denominator 20 over root 5. Well, what we'd do here is multiply both the numerator and the denominator by root 5. And if we do that, we have 20 root 5. Okay, so we've got here 20 root 5 divided by 5, which is equal to 4 root 5. Question number 14. Y is inversely proportional to the square root of x. So if we deal with that statement, we've got y, proportional symbol, and because we've got inversely proportional, we have over here a 1 over, and then here we've got the square root of x, as we see here. And then we know that when x is 25, y is equal to 7, and we have to find the value of y when x is 100. Well, from here, we can conclude that y is equal to k over the square root of x. And this is quite helpful. What we can do with this is find out the value of k. So, we have 7 equals k over square root 25. Now, square root 25, that's 5. So therefore, we've got k equaling 7 times by the square root of 5, which is 5. So k is 35. And knowing that k is 35, we can therefore conclude y equals 35 over square root x, and we have to find out the value of y when x is equal to 100. So when y is equal to 100, when x is equal to 100, we've got y equals 35 over square root 100. So we've got here 35 over 10, which is 7 over 2, or 3.5 if you want. So we've got y equals 7 over 2. Question number 15. You may use this coordinate grid to help you answer the following questions. For part A, we have to describe fully the single transformation that is equivalent to a translation of minus 7, 2, followed by a translation of 3 minus 5. Well, if we deal with this first, well, we've got a translation minus 7, so if I pick this point, we've got 1, 2, 3, 4, 5, 6, 7, and then we've got 2 up, so then we've got 1, 2. So if we draw the new shape, that goes over here, and then what we're doing is translating by 3 minus 5. So if I deal with this one here, if I pick this point over here, we've got 3 across, so we've got 1, 2, 3, and then 5 down. So then we've got 1, 2, 3, 4, 5. So if I draw that on, we've got this over here. So now we need to find out what doing these two transformation is equivalent to. Well, if we pick, say, this point, and the corresponding point is over here, well, what we're doing here is we're going 1, 2, 3 units down, and then we have 1, 2, 3, 4. So we go 4 to the left and 3 down. So this is equivalent to a translation minus 4 minus 3. And now for part B, we have to see what we have when we have a reflection in the line y equals x followed by a rotation 90 degrees clockwise about the origin. Well, if we draw the line y equals x, well, here is the line of y equals x, and if I transform this in the line y equals x, we'd have something looking like this over here. And then so this was over here the reflection in the line y equals x, and then we've got a rotation 90 degrees clockwise about the origin. So if we do that, rotate this about 90 degrees about the origin, what we'd end up with is a shape that is going over here. So if I rotate this about the origin, we end up with this. Question number 16. 50 people attended an outdoor activity. 40 took part in walking, 18 took part in sailing, and 3 did neither activity. One of the people who walked is chosen at random, and we have to find the probability that this person also sailed. Well, what we'll do is begin by creating a Venn diagram, and it makes sense for me to create a Venn diagram. We've got a set of people and we've got 2 categories here. And one of those, you'd see here we've got 3 who did neither, so outside of our circles of the Venn diagram, we can include this 3. So let's create a quick Venn diagram. We begin by creating 2 circles, something like this. And then we've got a box around this, something like that. So what we have here is the activity of walking, and we've got the activity of sailing, and we've got a set of people here. Now we've got 50 people in total, and we know that 3 people did neither activity, so we've got 3 over here. And then what we also know is 40 people took part in walking, so if we deal with this statement, we've got here 40 people in total who took part in walking, and what we also have is 18 people who took part in sailing, so we have 18 people who took part in sailing. Now the way to approach these questions is to let the intersection point be x, and if we do that, what we'd have for walking only will be 40 take away x, and what we'd have for sailing only would be 18 take away x, and the total number of people we have is 50. So we have 40 minus x plus 18 minus x plus the 3 equals 50. So tidying all this up, we've got 40 plus 18 plus 3, that's 61. So we've got 61 minus x equals 50, and therefore x is equal to 11. So with x equaling 11, if we go back to the question, we want to find out the probability that we've got a person sailing given they walked. So what we have over here is the probability of sailing given that we do some walking. Well, how many people do walking in total? We know that's 40. And of those 40, how many do sailing? Well, we've got x over here, which is... Question number 17, we have to show that the cube root of a to the 4 times 1 over a can be expressed as a to the power of 1/3. Well, first of all, cube rooting something, that's the same as raising something to the power of 1/3. So we have here a to the power of, rather here we've got a to the power of 4 to the power of 1/3 being multiplied by 1 over a. And if we multiply the question number 18, the graph of 3y minus 6x equals 13 is drawn. So here we've got 3y plus 6x equals 13, that's drawn. And on this grid we've got the region R which satisfied these inequalities. We've got 3y plus 6x being greater or equal to 13, y being less than or equal to 2, and x being greater than 3. Well, first of all, you'd find here we've got a weak inequality symbol, so we need to use a straight line which is not dashed. We've got another weak inequality symbol here, so again we need to use a straight line which is not dashed. So if I draw the line of y equals x minus 2, we have the line of y equals x minus 2 looking like this. When x is 0, y is minus 2, and when y is 0, x is 2. So if I draw this line, what we have over here is something looking like this. So we've got here the line of y equals x minus 2, and then drawing the line x being greater than 3, well, what we'd have over here, because we've got a strong inequality symbol, we'd have a dashed line. So we draw the line x equals 3 and then put a dashed line as we see over here. So essentially what we have here is line x equals 3. Now what we need to do is shade in the feasible region. Now to do this we can pick the origin as a testing point. So if we choose the origin, considering this inequality here, well, we've got 3 lots of 0, which is 0, plus 6 lots of 0, which is 0. We're questioning, is this greater or equal to 13? So we're questioning this point over here at the origin. Now because this is not true, we don't want everything below the line here. So we shade in this region over, well, what we'll do actually is, we'll do it over here. We shade in this region over here. And if we consider again the origin, well, what we'd have here is 0 being less than or equal to 0 minus 2. Now is this true? Well, this is also not true. So we don't want everything above this line. So we shade in this region here. And then we've got x being greater than 3. Well, we want everything to the right. So we want everything on this side, so we don't want everything on this side over here. And therefore, for our feasible region, we'd have something looking like this. So let's just add on all our relevant lines like so. Remember to include dashed lines. Our feasible region would be over here. Everywhere in blue is everywhere what I don't want. So that's how we go about these. We test points, and typically we test the origin. It makes life easier for us. Question number 19 for part A, we have to write down the value of sine 45. Well, sine 45 quite simply, that's 1 over root 2. Now for part B, ADB, so that's this right angle triangle, and BCD, that's this right angle triangle, well, that's shown here. And then we've got BC, so we've got BC equaling CD. So we've got here this equaling this, and because of that we've got an isosceles triangle, and therefore this angle here will equal this angle here. We've got the base angles on an isosceles being equal. And we've got BAD, the angle BAD rather, being 30 degrees, and we've got AD equaling 10 root 6 millimeters. And we have to find the length of BC. Well, what we can do here is find out what BD is. BD, using trigonometry, well here we've got the opposite. So we've got here BD over the adjacent, which is 10 root 6. This is equal to sine 30, and therefore BD is equal to 10 root 6 times by sine 30. Now we know what sine 30 is. Rather, here we've got tan 30. So apologies for that. So tan 30, we know that tan 30, that is root 3 over 3. So we've got here 10 root 6 times by root 3 over 3. So how does this help us? Well, what we can now do is find out what BD is. Question number 20 for part A, we have to write x squared minus 6x plus 11 in the form x minus a all squared plus b. Well, here we'd have to complete the square. So halving the coefficient of the x term, we would have x minus 3 all squared, and then we subtract off 3 squared, and then we're adding on the 11. So we've got x minus 3 all squared minus 9 plus 11. Of course, we have here x minus 3 all squared plus 2. So we have x minus 3 all squared plus 2. And now for part B, we have to sketch this graph showing any turning point. Well, first of all, from here, you can see that y equals x minus 3 all squared plus 2. The coordinates of the turning point will be 3, 2. And when x is 0, y is equal to 11. So we sketch a quadratic with the minimum turning point being in this first quadrant. So we have something looking like this. Here it crosses at 11. Here is the turning point with coordinates 3, 2. So here we've got y equal, well, we've got the graph that we wanted to show. Question number 21. In this question, all units are in centimeters, and a circle has equation x squared plus y squared equals 36. Well, here you can see then that the radius is equal to the square root of 36, which is 6. So writing down the radius and the center, well, the radius here will be 6 and the center will be at the origin. And then for part B, we have the distinct points A with coordinates A root 11 and B with coordinates B root 11, which lie in the circumference, and we have to work out the length of AB. Well, what we'll do to begin with is draw a circle. So over here we've got our circle, and then we've got the points A and B. Now the y coordinate is the same at root 11. Now if we were to add those on, the y coordinate's the same, so somewhere here and here we'd have the same y coordinate. We've got different x coordinates, however. So here we've got b root 11. Now there's nothing stopping us putting b on the other side. We could do that if we want. But there you go. We have to work out the length AB. So here we've got the length AB, which we need to work out. So let's just add in the relevant coordinate of B and A. And we've got over here 6, because that's the radius. And here we've also got 6. So what we need to do is work out what this length is over here. Well, to do that, what we need to do is recognize using Pythagoras that if we split this up using a triangle like so, we are going, say, m units across, and we're going root 11 units up. So if I construct that triangle once again, just to make things clearer, we've got a triangle, a right angle triangle looking like this. So we've got m root 11 over here, and here we've got 6. So through Pythagoras we can actually find out what m is. So we have m squared plus root 11 squared equals 6 squared. So m squared plus 11 equals 36. M squared is 25, and therefore m is equal to 5. How does this help us? Well, here what we're saying then is we've got 5, and here we've also got 5. So therefore for AB, this is equal to 5 plus 5, which is 10. So we've got 10 centimeters for AB. So that's the end of the paper. Don't forget to like, share and subscribe. Any questions, please feel free to comment them in the comment section below. And hopefully I'll see you all in the next video.